Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, maximum number of vowels in a substring of given length. So with this problem, we have a string s and we have an integer k. And we want to return the maximum number of vowels in any substring of s with length k exactly. And so we are given the vowels here. So let's see this example. Length 3, and so we want the maximum number of vowel letters in any substring of length 3. And so of course here the maximum is 3 because of these 3 i's, right? This is the max you can have. Now with length 2 the maximum here would be this, and let's say for length 3 it would be for this case either this one or this one, right? You could also do this one. All of them have maximum number of vowels of 2, but no greater, right? And so we return 2. So that's the idea here. Now, if we look at the constraint, this is the length of the string can be up to 10 to the power of 5. So this means we can't do an over squared solution. So we have to find a more optimal solution. Okay, so let's see how we can solve it. Well, this is a very classical example of using sliding window, because whenever you want to find the max in a window of either a string or array of some fixed length, usually that should be solvable with sliding window. But how do we apply it here? Well, all we need, since we have k, so for example in this example k equal to 3, we start out here and then we just move our window every time by 1, right? So, and then we check this one, and then we check this one, and then we check this one, right? And then we check this one, and you get the idea. Each time we slide our window by 1 here and then 1 here, okay? Now, we don't want to recalculate the number of vowels each time. Here is we can just keep track of the number of vowels, right? So let's say, for example, let's call them the count, okay? So let's say, for example, we had A, B, E, D, right? And then maybe G and I, and then K, something like this, right? And so the count here at this point with E, the count would be 2. But once we move to this window, what should we do? Well, since A here is a vowel, we should subtract 1 from our count. But since this D is not a vowel, we don't increment. And so you can see it's easy because we can just check the element that the window just moved from, this one. We can check. If it's a vowel, we need to subtract from our count. If it's not a vowel, we don't subtract, right? Because let's say, for example, this was actually K. Then we don't subtract, and maybe this was I, and the count was 2. Then when we move out of this K, we shouldn't subtract because it's not a vowel, okay? And so that's how we will maintain our window. The other case is, let's say, what if this here was I, right? Now in that case, because this is a vowel, we will also increment our count. Okay, and so this basically means as we move our window, we only need to check this and this. The one we moved from and the one we moved to. If they are vowels, then we decrement for this one, we increment for this one. And that's pretty much the idea here. And so, yeah, we can just, what's this position? Let's say we are at a position, this position, let's say it's I. Then we just need to check I minus K, right? Because, for example, 3, this would be just minus 3 if it was of length 3. And so we just check I minus K. If it's a vowel, then we subtract. If it's not, we don't subtract. And then for this one, we check at I. If it's a vowel, we add. If it's not a vowel, we don't add, right? And so, and then each time we, of course, at each window, we get the best value. And so let's apply it to this example and just make sure we understand it. So now in this case, what we do here is we have a count and we need to have also the best value so far, okay? And so we keep moving. So first I is here. Before I is at least K minus 1, because we start numbering from 0. So before I is equal to K, at least K minus 1, we don't we don't update best, right? But once it is, we update best because that means it's a window, it's a valid window. So here I is 0, and so it's a vowel, so increment 1. We move here, it's not a vowel, and so we don't increment anything. We move again. It's C, it's not a vowel, so we move. And now now our window, since the length is 3 here, then we can update best, right? So we update with the best so far, which is 1 is bigger than 0, so we put 1. And now our window is, we move our window. Now our window is here, which means we will check, is A a vowel? It is, because this is I minus K. It is a vowel, and so we subtract 1. So now it's 0. We check this position here, I, it is a vowel, and so we increment by 1. And then we move our window again. Now our window is here. We check this I, it is a vowel, so we increment by 2. We check the one before, so B is not a vowel, so we don't increment. And so we update our best to 2. We move here. And now for this window, we need to remove I minus K, which is C. Now is C a vowel? It's not, so we don't decrement anything. And then we want to add this one. Is I a vowel? Yes. And so we increment our count, and then we update here, so it becomes 3. We move again here. Now our window is this, so I minus K is I. And so that's a vowel, so we subtract by 1. And you get the idea. I won't finish everything, but you get the idea. The maximum would be this 3. And so this is just a classical sliding window technique. Okay, so now you can see here from just the logic, we visit each character, or we go through each character only once, okay? So we just do an O event traversal. So the time complexity should be O of n. And these are just variables, so we are not using really extract space, so it's O of 1 time. O of 1 space, O of n time and O of 1 space. Yeah, so that's pretty much it. Now let's code it up and make sure it passes. Okay, so let's implement the solution we just saw in the overview. So we need vowels, which are just these. These are the vowels we have. And then what else do we need? We need the count, and we need to know the best one. And then at the end, we want to return the best so far. And now we can just go through the string, so length of S. And we want to check for the letters we are adding. If it's in vowels, we want to increment the count of our window. And then the other case is if we already have a valid window, so we are moving our window, which means basically I minus K is bigger or equal to 0. That means we want to check if we should remove the element the window just moved from, right? So the element at position I minus K. So we want to check if that element is in vowels. If it is, then we want to subtract it. Exactly what we did in the overview. And now we want to check if this count is the best we have so far, this count here. And so we do best equal to the max of the best so far in the count. But we should be careful here. For example, for index 0 and 1, when K is equal to 3, we don't have a valid window yet. And so here we should check if we have a valid window, which, because we start indexing from 0, it's going to be when we reach K minus 1. Okay, and so that should be it. Now let's run this, make sure it passes, submit, and that passes. Okay, yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.